Hey guys, hope you're having a good day, had a good weekend. Okay, so over the next 2 weeks, you guys are going to be doing a lot of writing like hypotheses and different predicted results. Nick has, I feel like, really emphasized how to write these. Um, and so use that guidance, but I dive in and get a little more specific than what Nick does and how to write these, because I do feel like I see some kind of confusion between the two different types of statements and what should be included in each statement. So let's get into it. I even color coded the different kind of little parts during this whole presentation to kind of help you see how each of these little parts is used. So the hypothesis, like Nick says, you should have rationale and then tell us like an effect or like what's going to happen. Um, you should have your independent variable, and it should be tied to your biological process. Like you should be providing a relationship between your independent variable and your biological process. Okay, but then to write your predicted result, you should be taking your treatments and you should be telling us like the outcome of those treatments in terms of your dependent variable. Okay, so again, hypothesis needs independent variable and your biological process that you're studying. Your predicted result needs your dependent variable and your treatments. Okay, so to write these two types of statements, that means we need these four parts. We need both the variables, the process, and the treatments. Okay, so I've made this little kind of chart that we're going to be filling out together throughout the presentation. So if you are working on your experiment at home with this, feel free to write this down on a piece of paper, or you could even print this slide out if you wanted, and then just go ahead and write on it if that makes it easier for you. But anyway, okay, so to get these four different parts, actually the best place to start, or where you're going to get a really good hint of where to start, is your causal question. So your causal question is the thing that you wonder or that you ask yourself that kind of like prompts you to start with your experiment. So it is causal question, not casual question. As casual as your question may be, because it's the question that, again, causes you to actually go do your experiment. Okay, so I was wondering if fertilizer helps plants grow, could it help with respiration too? So again, in this statement, we already have a hint for what our independent variable here in red is going to be and what our biological process is going to be here in blue. Okay, so it looks like I'm interested in studying the effect of fertilizer, and I'm going to study it with respiration as a process. So let's go back and plug that into our chart. Okay, so if I were to just leave it at fertilizer, that's actually not specific enough. I could be talking about the brand. I could be talking about the amount. I could be talking about the time that you actually apply the fertilizer. There's a lot of different things I could be talking about, so that is not specific enough. So don't just leave it at that. I would want to specify I'm talking about, or I'm studying the effect of the amount of fertilizer, right? And then you guys already know aerobic respiration or rate of aerobic respiration is what we're studying for our process this week. Okay, all right, so now that we've got those two things, we can put them together into a statement to make our hypothesis. So to start, we could just say, as the amount of fertilizer increases, the rate of aerobic respiration will also increase. Okay, so that's a good start, but again, we need that little rationale part that Nick talks about. So we want to actually get a little bit of context or logic as to why we think that like increasing the amount of fertilizer is going to help. So we're going to go ahead and add a statement. So it says, because it provides vitamins that act as coenzymes, as the amount of fertilizer increases, the rate of aerobic respiration will also increase. Because you guys probably know, again, about like all biological cycles, those are run by enzymes, right? Enzymes run the world. So I think that the vitamins that are in there, because enzymes do need coenzymes, like things like vitamin that actually are vital to their function. So, so that's my rationale, is that it's providing coenzymes for the enzymes that run aerobic respiration. So the more of that material that they have, the rate can go faster. One thing I do also want to point out is that notice that I didn't just say like the amount of fertilizer will affect the rate of aerobic respiration. Okay, that is too vague. Okay, that is not specific enough for what you need to be doing. You need to DTR, okay? You need to define the relationship between between the independent variable and the biological process. So if you submit a hypothesis to me that says fertilizer will affect respiration, like, nope, you need to turn around and you need to redo that. You need to define that relationship. So we're saying as one increases, the other will also increase. Maybe you think as one increases, the other will decrease, or as one decreases, the other will increase. Maybe you think that there's an optimum, like it would look like a bell curve if you chart it out. Okay, so there's a lot of different relationships that could exist. So again, you need to define what that relationship is between the independent variable and the biological process. All right, so cool, we got that. So let us look at the next statement that we need. So we did our hypothesis, so that means that we need to do our predicted result. And once again, the predicted result is going to marry the dependent variable with the different treatments that we have set up. So you guys, what measurements are you taking, or how are you measuring respiration this week? You guys are looking at the time to change color in the bromothymol blue. So you guys have your chart, and every 15 minutes you're going to write down you're going to make notes about what your bromothymol blue looks like. So that's what you're measuring this week. And then for my different treatments, the fertilizer I use with my plants is called Turboganic. So I'm going to have one treatment where I soak the beans with just water. I'm not going to soak them with any Turboganic. I'm going to have one set up where I put 3 mils of Turboganic into the bean water. And then my last beans are going to be soaked with 6 mils of Turboganic. So notice in my treatments, my different setups, I've specified the amount. Like I've been very specific about how much fertilizer is being used, since my independent variable is amount of fertilizer. Here I'm expressing that in very specific terms. And then also notice that I didn't just say like 0 mils of fertilizer, 3 mils of fertilizer. I said Turboganic. I told the specific fertilizer that I'm using. Because again, if I just said 0 mils fertilizer, 3 mils fertilizer, I'm like, okay, do you mean Miracle-Gro? Do you mean compost? Like, do you mean horse manure? Like, what do you mean as fertilizer? So again, this should be very specific to your experiment. Okay. All right, so now that I have the dependent variable and the treatments, I can put those together to go ahead and write a predicted result. So again, it's all color-coded for your convenience. So here we have the beans soaked with 0 mils of Turboganic will change the color of bromothymol blue the slowest. Beans with 6 mils of Turboganic will change the color of bromothymol blue the quickest. And beans with 3 mils of Turboganic will change the color at a speed between the other two. So when you guys are writing your predicted results, some people will get super specific, like impossibly specific, like you can't predict that if you haven't done it before, where they'll say like, bean soaked with 6 mils of Turboganic will change the color of bromothymol blue within 15 minutes. Bean soaked with 3 mils of Turboganic will change the color in 45 minutes. Like you don't need to say that. You can just rank them. Just rank who's going to be fastest, who's going to be slowest, and who's going to be in the middle. Okay, because that is what establishes the trend that we expect to see. So then we can look at your data and say, did your data follow the trend, yes or no? Because the other big mistake that people make when writing their predicted result is they'll just say, beans soaked with 6 mils of Turboganic will change the color of bromothymol blue the quickest. And that's all. They don't say anything else, okay? You need to address all 3 of your treatments because we can't establish a trend off of one data point. So if you're only telling me what you expect to happen with one of your treatments, that's not good enough. You need to give me, again, you need to lay out a trend involving all 3 of your treatments. Who's going to be fastest, slowest, and in the middle, or whatever order you want to do that in. Okay. Sorry, just waiting to change slides. There we go. Okay. All right. So it looks like we got all 4 of our parts, which means that we were able to put them together to make our 2 statements. So great. We're done with that. So let's look at our just statements by themselves. So let's read the hypothesis again one more time. Because it provides vitamins that act as coenzymes, so that's our rationale, as the amount of fertilizer increases, the rate of aerobic respiration will also increase. So again, we have our little chunk of rationale or our logic for why we think this is going to happen. We've included our independent variable, our biological process, and we've defined the relationship between them. Okay, then when we look at our predicted results, we have the beans soaked with 0 mils of turboganic will change the color of bromothymol blue the slowest. Beans with 6 mils of turboganic will change the color of bromothymol blue the quickest. And beans with 3 mils of turboganic will change the color at a speed between the other two. So there we go. We've got all 3 of our treatments, and we've given a predicted outcome for each of those treatments. And that way we can see a trend in the treatments, or sorry, we can see a trend, between the treatments when we go to look at our results. Okay, the other thing, I kind of mentioned this earlier, but the last thing I do want you to notice is that the hypothesis is not, it's less specific to your experiment. You could test this a lot of ways. For example, when we test rate of aerobic respiration in the classroom, we have sensors that we plug into a chamber that actually like measure the number of CO2 molecules and O2 molecules in the chamber. But you guys are doing it with bromothymol blue, right? But they're both ways to test aerobic respiration. So this is not the most specific thing to your experiment. However, when you get to your predicted results, it should be like very specific to your experiment, and we should be able to, understand your experimental setup or start to have ideas about your experimental setup from your predicted result, okay? Because again, we've told the exact amounts of fertilizer that we're going to be using. We have said we've ranked who's going to be fastest, slowest, in the middle, and then we've specified exactly which fertilizer we're going to be using. Because again, if I just said fertilizer, like what does that mean? Does it mean compost, Miracle-Gro? But now from this statement, we know, okay, she's using one called Turboganic. So anyway, okay. I hope that helps you guys with writing these. Just make sure that you follow this formula and you will get 100% on your hypothesis and predicted results. You're going to be writing these a lot the next couple of weeks, and you need to be doing it correctly. Okay, you need to just start doing it this way. So yeah, just please make sure you're following this and that you ask questions on our discussion board or email me when you have questions about it. That's where I think I put in most of the time with helping people, is with getting these statements written correctly. So yeah, just use the appropriate language and you'll be fine. So I hope that helped you, and I hope that you guys enjoy doing this inquiry-based stuff the next couple weeks.